Lauren Zajan, representing our bioimaging program. Lauren, please come to the podium.
Yay! Woo!
Don't overdo it, but one of your teachers commented that you are one of the most talented, intelligent, promising students in the entire history of the bioimaging program.
Wow.
It's not only flattering to you, but it's music to my ears, as I know that you will be joining us next year in GMS as a doctoral student. It was also noted that you are equally at home in the world of imaging sciences, neurosciences, and you are highly autistic. Having had a preview of your speech, I second that thought. Lauren.
Yay! Gets no whoops. Wow.
Thank you, Dr. Halfway through my time in the bioimaging program, it was changed from a Master of Arts program to a Master of Science program. Nothing about our requirements, experience, or coursework changed with the title, only the words that described what we completed and perhaps our perception of ourselves. Many of us in bioimaging entered into an MA program, but we graduate today with an MS and a potential crisis. We've been educated to master art or science. Let's look into this with a brief experiment. What does the title Master of Science evoke in you? How about Master of Arts? I bet each evokes different ideas of the nature of the skills we acquired. Imagine me as someone who has mastered the art of bioimaging. Got it? Okay. Now, imagine me as someone who has mastered the science of it. Chances are, you see me differently. We see these titles differently because society has taught us to. If we hold separate ideas of what science is, what art is, and who the people who practice each are, then we will limit ourselves. Now I admit that I seize any opportunity to talk about why I think art and science are one and the same. Those who know me know that I made it my life's mission to convince people of this several years ago. But given that we are here today at the MAMS ceremony to celebrate that we have mastered both arts and sciences, I consider today an especially relevant occasion to discuss this. In the bioimaging program, we work with images. We behave as critics, curators, and artists. Interpreting a medical or biological image requires a set of skills similar to those required to interpret a work of art. Both artistic and biological images are representations, carry information, and are the products of human experimentation. Artistic and biological images are also capable of illuminating human beings. Artistic images illuminate the workings of the human mind, and biological images illuminate the workings of the human body. Both communicate information without words, but require one to be proficient in a certain language.
I don't know. Sorry, no water.
It's allergy season. On the first day of sectional anatomy, Dr. Sewick began to teach us to see images through our eyes before seeing them through our minds. He instructed us to take in the elements of an image, focus on what was in front of us, and use that information to deduce where in the body an image was acquired. You would think that describing an image would be simple. Well, I can't tell you how bad we were at being able to describe what we saw and suppress the urge to respond with an answer. Here's what you would have witnessed if you were there. Tell me what you see. Is it an axial view of the neck? No. Tell me what you're looking at. So we went back and forth until we began to respond that we saw areas of light and dark arranged in a circular structure, as though we were describing an abstract game. Dr. Sewick exposed that we were blinded by the idea of answering a question. Slowly but surely, we let go of what our minds attempted to decide we saw, which was the neck, and we were able to eventually see the images first. In time, we were convinced to use our eyes, because when we were shown confusing images, when we didn't have an answer, as you can imagine, seeing the image was pretty important. In image processing, Dr. Kiliani taught us how to interact with images in order to extract information from them. In one assignment, we were given 2 sets of brain images and used a computer program to determine if they were different. The result of a series of steps that we performed in the program was a cartoonish outline of the brain. Regions that differed between the two sets of images appeared light or dark gray. Regions that didn't differ appeared white. After a few attempts, we were excited to get results that suggested the program worked. The following week, we compared our results to see if they were similar. To our surprise, none of our images looked the same, and they were supposed to. We learned you need to be familiar with your tools and process when altering images, the same way a photographer would know her camera. Creating a cool image doesn't mean it holds the information you intended it to hold. In fact, it may not hold any information at all. In Bioimaging Foundations, Dr. Hara constantly pushed us to get to the core of what both words and images mean. He helped us understand the connection between the physics and physiological processes behind different images so that we could truly understand and thoroughly explain them. He constructed analogies between the way a chorus of singers behaves and the way a chorus of millions of hydrogen nuclei in an MRI scanner behaves. We've been taught to see, create, interpret, and transform images. So I ask you, which title better describes what we've been taught to do? MA or MS? Are we scientists or artists? I hope I've blurred that boundary for you. The process of creating art is a science. The scientific pursuit of a question is truly an art. The two are intertwined and inseparable. Great artists develop methods to produce the works we see in a museum, a specific kind of paint, a particular motion of the wrist to create a signature mark, a layering process that makes the painting shimmer in a certain light. In a similar way, great scientists, through trial and error, develop methods to produce work that beautifully demonstrates an idea or model. They spend months planning and performing experiments that result in a figure that demonstrates their results. A work of art. Artists and scientists practice rigorous work, both constantly create, perfect their processes, and are masters of observation. I now have a few pieces of advice to share. The first, consider your work your art. Create, develop a style. People will recognize you, and you will do work that feels like your own. The second, a picture is not worth 1,000 words. After spending a year and a half in the bioimaging program, I'm absolutely positive that an image is worth significantly more than 1,000 words, and potentially hundreds of hours and thousands of other images. Please don't undervalue images with that statement. With that, I want to thank all of you for being present at this ceremony today to celebrate our accomplishments. I congratulate everyone who is graduating for becoming masters of ideas and discovery. On behalf of my classmates, I want to thank our parents, families, friends, significant others, the Division of Graduate Medical Sciences, and everyone who has played a role in supporting us and helping us master the art of our sciences. I especially want to thank everyone who is involved in the bioimaging program. You have been wonderful, and you've shown us that you have our best interests at heart. I've truly enjoyed learning from you, and I'm honored to have been asked to share my thoughts today. And finally, my last piece of advice. Be artists, be scientists, but above all, be curious. Curiosity is a natural precursor to the practice of art and science. Be curious. I guarantee that you will seldom be bored. Thank you.
At commencement, we honor outstanding service of select faculty members